Hello, everyone. Good evening. I'm Professor Daniel Chua. I'm a professor of music here at the University of Hong Kong, also Director of Faith and Global Engagement. Welcome to the McDonald Faith and Global Engagement Distinguished Lecture. Now, many people are still, of course, enjoying an extended holiday somewhere because of the extraordinary weekend we've just had. Did you have a good holiday? Was it okay? Nice, super long, extended holiday weekend. What an extraordinary coincidence that Easter and Qingming should be on the same day. It's like an overdose of death and graves and resurrection all at once. And I was hoping actually that our speaker for today might be inspired by this alignment, right? This auspicious alignment and speak on some suitably Easter Qingming theme. But he's decided to talk about zombies, right? Which is like Easter gone wrong or Qingming gone wrong, right? It's like, I don't know, you're sweeping your grave and your great-great-grandfather turns up as a zombie or something. Or Easter, can you imagine? The resurrection of Jesus as a zombie. That was terrible theology. Terrible, terrible. But of course, zombies are also what happens when science and religion goes wrong as well. And they are myths, zombie myths, precisely because it's bad science and religion. And these are myths that need to be busted. And I can't think of a better myth buster and zombie slayer than our speaker for this evening, who is Ard Louis, Professor of Theoretical Physics from the University of Oxford. He's not just a normal theoretical physicist. I think he does all that kind of stuff. But if you look at what he's doing now, he seems to be rummaging around in all areas of the sciences. I think what he does, I'm not a scientist, I'm a musicologist, but I think what he does is that he applies theoretical physics principles and methods to other areas of science, such as biology and chemistry, working on evolution, working on machine learning, and many, many other things. So he's absolutely qualified to talk about this because he really covers the whole spectrum of scientific inquiry. And he's also a little bit famous because you might see him on TV or in a documentary. I think he's appeared with Morgan Freeman in some kind of show on religion and science. And also he's made a documentary with a very well-known documentary filmmaker called David Malone. Malone, I think, is that right? Yeah, on Why We're Here. So the filmmaker's an atheist, Ard obviously is a Christian, and they have this wonderful kind of dialogue together as they talk to different people. So he's kind of a little bit famous as well. So please join me in welcoming our speaker for this evening, Professor Ard Louis from the University of Oxford. Welcome. We've been trying to get you here, for 6 years, so I'm so glad you finally made it. Thank you. Thank you for coming, Ard.
Thank you. So actually, the auspicious thing was that the holiday, the timing here worked with the holiday of my children, who I was able to bring along. And that's how I was able to convince my family to let me come. So it's a great pleasure to be here in Hong Kong. I love being here. It's a wonderful city, and it's a great honor to speak here at the HKU, which is a great university, and to speak about something that's very close to my heart, how science and religion interact with one another. I'm going to talk a little bit about science first. I always want to talk about something cool about science, because I think it's amazing that I get to do science. And even if you're not a scientist, I hope that you'll at least pick up some of the joy that comes from doing science. So here's one of my favorite stories in science. It has a very personal aspect to me. And this is from the great Cambridge physicist. Cambridge is also a good place, like Oxford. It's a bit younger than Oxford. Paul Dirac, a great genius, one of my scientific heroes. And this, what I'm showing you, don't worry about these equations. I'm just going to show you this equation, which is a Schrödinger equation, which is the theory of very small things. If you heard of quantum mechanics, it basically explains how very small things work. It's an extremely powerful theory. And down below here is Einstein's special relativity. So if you look at this, this is E is mc squared, right? The square root of mc squared is just mc squared, plus some, if you're moving, you get some extra terms. It's a slightly complicated equation, but it's basically an energy equation. E is mc squared, you remember that from Einstein, that's 1905 actually, so 20 years before 1926, when the Schrödinger equation was discovered. And in 1928, just 2 years after Schrödinger's discovery, the great physicist Paul Dirac was trying to combine quantum mechanics, theory of very small things, with special relativity from Einstein, E is mc squared, what happens when things move very fast. Okay, so those are two very different parts of physics, very different set of ideas. But it's an obvious question. If something is very small and also moves very fast, what will happen to it? So we looked at the electron. Okay, the electron is a particle that can spin up and spin down, so we tend to treat it with two components, a two-component equation. Electron is what all of chemistry is really studying the properties of electrons, so it's a kind of cool thing to study. What happens if it goes very fast? And it turns out that if you want to make this electron go very fast, you write down this equation here, which looks a bit abstract, but one of these are actually bigger things, and it turns out that what was here, a single object, becomes two objects. And that's kind of strange. It turns out the only way you can make something follow quantum mechanics and special relativity is to add this other object. Now, Dirac believed in the power of mathematics, and so he just said, this must be true. He wrote down his equation. A few years later in Caltech, Carl Anderson discovered what this other thing was. This other thing was, as I've already shown you here, is a positron, which is antimatter. Now I'm going to get rid of the equations. I'm just going to show you these equations for a second because I'm going to refer back to them in a minute. So every particle in nature, like a proton or electron or neutron, has an antimatter complement. What's kind of amazing is if an antimatter and matter come together, all the mass turns into energy. So remember E is mc squared? It actually comes together. So you take a positron and electron, bring them together, and energy comes out. That's why if you go to the hospital and you get a PET scan, positron emission tomography, they're actually shooting antimatter at you, okay? Before you get too scared, there's a little bit of antimatter. And then when those positrons hit an electron, poof, they give a little light flash and they turn into energy. So the amazing thing is E is mc squared comes out of this stuff for free, but this crazy stuff called antimatter, which is like matter except that it's something completely different. If it touches matter, it blows up, basically, was not first discovered by finding it in the lab. It was first discovered by just thinking about it, by the mathematical consistency of very fast things and very slow things. So I think that is unspeakably beautiful. I think that's as beautiful as the most amazing painting, the most unbelievable piece of music, even from Beethoven, for Professor Chua. The most unbelievable nature scene. It's just unspeakably beautiful. When I first learned about this as an undergraduate taking an advanced quantum mechanics class, I was just completely, utterly blown away. I still get goosebumps thinking about it. Now, I realize that when you look at this thing, it doesn't look beautiful to you, and that's okay. I'm just going to tell you that it is beautiful. And what's beautiful is not the particular way I wrote it down, but what it tells you, what it means, the kind of way it takes two completely different, unrelated things and predicts something completely magical. The Nobel Prize winner Eugene Wigner wrote in the 1960s about this kind of discovery. He called the unreasonable effect of mathematics, a gift which we neither understand nor deserve. It's as if there's something about the structure and the order of the universe that's outside of ourselves, that allows us to peer into it in ways that we feel like we almost aren't allowed to. When you speak about beauty, you could also speak about the sublime. Sublime is the idea of the kind of experience you might get when you come to the top of a giant mountain peak and you look down and you just experience the vastness of what you see before you. Or when you're looking at a giant storm at sea and you watch the waves crash in and you feel small, something which is beautiful but also terrifying. And I think when you look at this and you understand what Dirac did, you feel something of not only beauty but of the sublime. And this got me hooked. I thought, I can't believe I can do this. I discovered I could actually get paid for doing it, which is even more amazing. And so it's unbelievable. My grandfather in the Netherlands had to leave school at 16 to support his family and worked his whole life at a factory. He rose up to a management role, but it never was really what he wanted to do. What he really wanted to do, I realized, was become an academic. I think he wanted to become an historian, but he didn't have that opportunity because the times were different then. But I'm lucky that I grew up in a time when that opportunity was open to me. And universities expanded, and people's tax money paid for people like myself to work. So if you're paying taxes, thank you very much. I appreciate it. You're helping people like me follow our dreams. I remember when my grandfather retired, he was saying, finally I can do what I really want to do. And he went and did his hobbies and things he wanted to do. Whereas at the university where I was at the time, there were many very old academics, physicists, who came in creaking, but they loved coming in. Well, 20, 30 years after retirement, still coming in every day to listen to physics, talk about physics. I thought, that's what I want to do. I want to do a job where I get paid to do what I love. I love it. It's beautiful. So I used to work on these kind of quantum things. I've now moved, as Professor Chua pointed out, to lots of more different things. And more recently, I have a discovery I made that I'm very proud of, which is why it's a theory based on, actually I'm using ideas from theory of computer science, applying them to evolution, so bridging two very different fields. And it's a theory that helps explain why you see so much symmetry in nature. And the New York Times actually even said it was a new law. No, I didn't say it's new law of nature. They said it's new law of nature. I'm not going to say that, too publicly, but they said it. I remember when I first properly understood this, and I walked out of my office, and I walked around the nature, and I just thought, wow, I've seen something about the way the world works that no one has seen before. And I thought, I can't believe that I'm the one that got to see this. It's unspeakably beautiful. And I cried because it was such an amazing, moving experience. And I felt a sense of the sublime, like I touched on something that was bigger and greater than myself. And this is the kind of thing that science does to us. It can point us beyond ourselves. It can show us things that are unbelievably and unimaginably beautiful. It's also true that science has made enormous progress. So look at my phone. This phone has more computer power than the computers that sent the first astronauts to the moon in the Apollo mission. So here you see that, those punch cards, I used to do them in 1966, just before the Apollo mission, that holds about 5 megabytes of data, which is about the same as one photo that I can make. If I make a photo of you right now, this is about 5 megabytes. I'll make a photo just to remind myself, there we go. That storage would take that many just, 60 years ago. So we've had unbelievable scientific progress. We're healthier, we're wealthier, we understand way more about the world than we did 60 years ago, 50 years ago, even 10 years ago. And science is progressing all the time. It's very natural to hope then that this incredibly powerful method that we've discovered would allow us to understand all the important questions. Questions like, what is good? What is evil? How should we organize our society? How should you live? What is a life worth living? As a class I just taught in a few hours ago is called. What does it mean to live a good life? All those kind of big questions that we don't really know, always can't agree on answers for, we dispute. What if this method that has brought us all this advancement could also answer those questions? And I'm going to argue at the end of my talk that a version of this idea, I'm going to call it soft scientism. So it's, people believe in the background that something like this will happen there. If it hasn't happened yet, it will happen. And I believe that this kind of soft scientism, not that carefully thought through, but definitely there in the public sphere, plays an enormously powerful role in suppressing actually what I think is needed viewpoint diversity. So hold on to that. At the very end, I'm going to explain to you about that. And one of the ways this works is that there are these myths about how science and religion come together. And I'm calling them zombie myths because like zombies, you try to kill them and they rise again. And you kill them and they rise again. They're very hard to kill. So I'm going to give you a few of these. One of them is that somehow, in the academic sphere, scientists don't believe in God. And I've been told this many times both by religious people. For Christians like myself, I might be in a church and somebody says, oh, you're a scientist and you're Christian. Oh, that must be very rare or strange or weird. And some of my science colleagues said, oh, you believe in God. That's kind of weird and strange, and how does that work? And I think what they sometimes think is that I'm basically like a vegetarian butcher, okay? So I sell something I don't really believe in, okay? Or maybe even more dangerously, I'm a pacifist soldier, okay? So I'm there in the scientific community, but when push comes to shove, when something really dangerous happens, I'm going to withdraw from the battle and they cannot be trusted. So I'm just going to, in Oxford, with some friends of mine, I run a course called Developing Christian Mind Oxford, which is basically Oxford academics that help Oxford PhD students and master students think about their faith and their subjects. So they think about faith in humanities, faith in the sciences, faith in the social sciences, faith in philosophy, every single subject. Maybe there's 100 of us that are involved in this, 100 of us academics involved in this. And the interesting thing is, in Oxford, I've got tons of scientists that want to come speak. I've got to kind of ration them a little bit so they all get their turn. Right? Whereas it's actually quite hard to find Christians in the humanities who want to speak. There are, but there are definitely a lot less of them. So there are more Christians in the sciences than there are in the humanities. And people sometimes say to us, these are some of my academic friends, why do you believe in God? How does that work? And we also say, I have a little quote I like to say, for us, Christianity is intellectually robust and existentially satisfying. We're very happy with it. We think there's deep reasons, rational reasons, intellectual reasons to believe that it's true, and we're happy to discuss those with you. And these are things that are very valuable. We don't think we're vegetarian butchers. We think that faith and our science interact in really beautiful, natural ways. If you're interested in a careful study of how many religious scientists there are, I recommend this work by Elaine Howard Eklund, who's a famous sociologist who's done the most biggest study of this, including a big 8-country study that included Hong Kong. Hong Kong is kind of interesting because Hong Kong and Taiwan are two countries where the fraction of religious scientists by various measures like prayer or religious attendance is higher than the scientists' childhood upbringing. So you look at what did you do when you were 15 years old and what do you do when you're now, and in Hong Kong, scientists tend to be more religious than their peers. So that's interesting. What you also learn from this study is that actually the fraction of scientists who are believers of some kind or the other correlates in each country with the general public. It's not the same as the general public, it tends to be slightly lower, but it correlates. And this tells you that actually what scientists personally believe about big questions of life, the questions of meaning and purpose, etc., tends to be a lot less correlated with their science than you might think. It actually is much more affected by their cultural upbringing. And that's an important thing that's going to come back in a minute. That's zombie myth number one. The second zombie myth, which is very pervasive, is a kind of progress myth, or a related conflict metaphor for the history of science and religion. And the idea is a bit like this. In the Middle Ages and before that, people were not that smart. They didn't know very much. And the church kind of suppressed thinkers, but a few brave renegades, elbowed their way through. Galileo, name a few like that. They fought their way against these oppressive authorities. They were brave, and slowly but surely the truth kind of won out over superstition. And now we're continuously progressing, and all that stuff that we used to believe we don't believe anymore because that's been shown to be wrong, and it's bad. And this is a very common view. It's still the dominant view, I would say, in journalism. I hear this whenever people talk to me about science and faith. They say, "I always think, great that we overcame those myths of the past." So interestingly, if you talk to historians of science, people who actually study the history of science, they get really, some of the steam comes out of their ears when you say this. And so I'm just going to quote, rather than giving you a lecture on this, I'm going to quote authorities. This is Peter Harrison, who was professor of history and philosophy of science, who was Andrews Idris professor of science and religion at the University of Oxford, is now at the University of Queensland, who wrote already a while back, those who argue for the incompatibility of science and religion will draw little comfort from history. The myth of a perennial conflict between science and religion is one to which no historian of science would subscribe. And in fact, there's a bunch of books. This one, I think, is very interesting. 25 historians of science wrote a book called Galileo Goes to Jail and Other Myths about Science and Religion, where they're basically trying to push against the conflict myth. So the consensus among the professionals who study the history of this is that conflict is the wrong way of thinking about it. That doesn't mean that it was all clear sailing. It's just that there are times when religious convictions were very important in the rise of science, and times when it pushed back. And as always in history, things are more complicated and more interesting. But conflict is definitely the wrong way of thinking about this. So here's a book by Alan Chaplin, who just passed away actually, from Oxford, Slaying the Dragons, Destroying Myths in the History of Science and Faith. And so I'm just quoting authority at you. If you'd like to know more about this, these are good books to start. But the idea of this progress myth, the idea of conflict, is a myth. It's just simply not true. Another kind of zombie myth that's really hard to chop down, just like the conflict myth, which despite the fact that the consensus in the field has been that this is a myth for a long time, it's not entered into the wider public, including our academic public. It's just not, they haven't succeeded in the PR, as it were. But I think the interesting question really is why. Okay, this is another one that has not really been knocked down, but it's a bit more complicated. The idea is that believing in God is irrational, like believing in a pink unicorn or a flying teapot. And flying teapot is from the philosopher Bertrand Russell, and I'm going to give a more modern version from my colleague Richard Dawkins, which is the pink unicorn. I love Richard Dawkins because he's such a great writer. So you see, I quote him a few times because he says things so punchily. If you want to believe in teapots, so that was the idea that there was a flying teapot somewhere outside the Earth in orbit. You couldn't see it, but I believe in this flying teapot. And until that was how Russell thought believing in God was. And here, Dawkins says, if you want to believe in teapots, unicorns, or tooth fairies, Thor or Yahweh, the onus is on you to say why you believe in it. The onus is not on the rest of us to say why we do not. We who are atheists are also a fairist, a teapotist, and a unicornist, but we don't have to bother saying so. So interestingly, what's happening here is the following. Professor Dawkins is using a kind of posture of skepticism that we apply in science all the time, and is applying it now to this question of the belief in God. So how does this work? If I come to you and say, if you're a scientist, I say, I've discovered this new law of nature that I claim, that the New York Times said, or I claim to find a new virus. You are fully justified to be super skeptical until I show you evidence. The onus is on me to show you evidence. Okay? That's how science works. And it's true for any discovery. If I say there's some new planet floating around the solar system, the onus is on me to give you evidence. The onus is not on you to believe it until you see the evidence. That's how science works. It's a great way of making progress. But does this work for things like God? Well, here's something that's been slipped into this argument. What kind of God are we talking about here? It's a pink unicorn or a flying teapot or a tooth fairy is part of this earth, part of this universe. It's a God who's like us, but maybe bigger and smarter and lives out somewhere else. That is not the God of classical theism. The God of classical theism is the reason why the universe exists. In Christian theology, God sustains the world. In other words, the laws of nature that we see are describing the regular ways that God sustains the world. If God were to stop sustaining the world doesn't slowly grind to a halt. It just stops existing. Okay? God is necessary for the existence of the universe. So you can't posit a kind of God in the universe. That's just a category error. And so it sounds scientific, it sounds rational. It's actually kind of dumb because it completely misses the point of the kind of God. I don't believe in that kind of God either. And if you were to posit a God like that, I would say the onus is on you to give me evidence for that God. But that's not the God of theism. And so here's one of my favorite thinkers on this, John Polkinghorne, who was a very famous professor of physics who then turned into theology at Cambridge again. See, I'm quoting a lot of Cambridge things. Daniel ribbed me a little bit today about Oxford, so I'm ribbing him back about Cambridge, which is where he was. But Polkinghorne says, if we were to understand the nature of reality, we have only two possible starting points. Either the root fact of the physical world or the root fact of a divine will and purpose behind that physical world. So what he's saying is, if I want to make a rational kind of set of methods to try to think about the world, particularly these big questions like the ones that I'm going to talk about, I've got two starting points. One is that there's nothing but nature, perhaps, and one of them is perhaps some divine will and purpose behind them. You might give more than one, but take these as two starting points. What Professor Dawkins has done, and many people have done in that kind of pink unicorn argument, is they've basically assumed that they're starting from a physical world, and then you've got to go from there. That's an assumption. That's a big assumption. Who knows if that's true? The best thing you can do is start from one of these two perspectives and then look at the world and ask you which makes the most sense. So let me give you an example of how you might do that. Let's say you ask, why is our universe here? Okay. Why our universe? A better question for that would be, why are laws of nature? Okay. So why do we have the laws of physics and nature that allow our universe to pop into being or to exist or to whatever those laws of nature tell us about our universe? Where do they come from? Well, to first order, you've got three kind of options. The first one is that some kind of laws of nature have always existed. So the current laws of nature may be eternal, or perhaps they were caused by a previous set of laws of nature that were caused by a previous set of laws of nature. They were caused by a previous set of laws of nature, and you get some infinite regress. Perfectly rational starting point. Okay? If you believe there's nothing but the physical world, that's one of the options that you have, that those laws of nature have always existed. But the idea of it, something which has existed forever or something, or an infinite regressive causes, are both philosophical, metaphysical assumptions about the world. They're not science. Science doesn't have a category for those because science deals with causation. And this is something that's somehow outside that boundary. So you can believe that there's been this external, that's one of your options, you can believe that. And if you start from the brute fact of just the physical world, that's one of your options. The other option you have to first order is to say, these laws of nature popped into being out of nothingness. A fancy word for that is ontological nothingness, basically nothingness by which I don't mean a quantum vacuum with the laws of nature in there and something popped into it, but the laws out of nothingness, no laws of logic, no laws of mathematics, nothing, nothing. I don't know even how to imagine what that is, but it's a real true nothingness. And somehow our universe popped into being out of that. That's the second option you have as a naturalist, if you believe there's nothing but the laws of nature. That's also kind of strange, right? So the first options are really strange options. They're kind of strange, but you can break this down in more subtle ways if you want to, but to first order, you've got these two really strange options. They're kind of weird options. And if you assume there's nothing but the laws of nature, that's your brute fact to start with, then one of these two options is the one that you probably need to plonk for. There's a third option, which is the other kind of starting point, which is all of space-time is dependent on some non-spatio-temporal reality, what theologians traditionally call a necessary being, so a God who's outside of it at the same time. Also weird, fair enough. Okay? But my point is simply all three of these are philosophical, theological assumptions about the world. All three of them are kind of strange, and you don't have a choice really for a scientific way of thinking about this. It's a non-scientific question. Now, scientists make claims all the time that they've solved this. The theoretical physicist called Lawrence Krauss wrote a book called The Universe from Nothing. On the back of it, Richard Dawkins said, finally, we've put to rest that pesky question that theologians always ask for, why is something rather than nothing? But if you look at it carefully, Krauss basically has a theory for where universes pop out of the quantum vacuum, just like electron-positron pairs can pop out of the quantum vacuum. It's an interesting speculative theory, but it has nothing to do with the big questions that I just answered you. Everybody, including Professor Dawkins and Professor Krauss, will have to take one view of these kinds, all of which are strange. The next kind of the way I think about in the same category is the false binary of reason or faith. So Richard Dawkins says, again, I quote him mainly because he writes so well, faith is the great cop-out, the great excuse to evade the need to think and evaluate evidence. Faith is belief in spite of, or even perhaps because of, the lack of evidence. And the idea is that, if you have faith, you just have to believe, a lot of impossible things before breakfast, and you close your eyes and you try. I think that's a complete misunderstanding of how people of faith think about things. I think rationality plays a very important role in how we understand things. But I want to take a step beyond that and give a story that I learned from my friend Bill Newsom, who's a professor of neuroscience at Stanford. So Bill told me he's once walking across the Stanford campus. Stanford has this church called Memorial Church, and his colleague said, I really dislike this church, we should blow it up. It's a monument to irrationality. Well, she meant religion is irrational. At which point, Bill quipped and said, well, then we should blow up my house. It's also a monument to rationality. And the friend said, why do you blow up your house? He said, well, look, my house is where I live with my family and my wife. And I didn't use the scientific method to decide that I was going to marry this person. You don't really want to use this method for all kinds of reasons. You don't want to do repeatable experiments. You don't want to... In fact, there's something really interesting about this kind of important decision. So I am married very happily. I told you my wife came, which is one of the reasons why I was able to come this time. And if I were to use the skeptical methods of science to evaluate whether or not I would be married to her, that would cause problems. And one of the reasons that would cause problems is because as much as I wanted to get married, I don't really know what it's like to be married until I make a step of faith and I'm married. I can hope that it's going to be good, okay? But I can't get evidence that marriage is good until I'm married because I have to take a leap of faith. I have to step into a new state in order to see that evidence. There are many important things in life that have this character that you can not really understand or see until you make some kind of volitional step. The philosopher Michael Polanyi writes a lot about this. So many of the important questions in life just have that character. It's just the way the world is. Nothing you can do about it. A scientific skeptical method doesn't work. It gets even worse than that. If I were to use the scientific skeptical method with my wife, okay, then let's say I use that to try to have her prove that she loves me. I'd say, well, I don't really believe that you love me because I'm a scientist. I'm skeptical about things until I see evidence. So I'm going to wait around until you show me evidence that you love me, and then I'll believe it. Okay. Well, as you probably know, I see some married people laughing because I know exactly what would happen. Right? I would miss a lot of evidence of her love for me if I behaved that way. Instead, I need to believe that she loves me, behave in a way that's consistent with that, and the love will grow. Now, does that mean that I'm irrational about it? No. If worse comes to worse, something happens terrible and my wife stops loving me, I can't just keep putting my head in the sand. I've got to recognize that, maybe go to counseling or try to help or do something, right? Pull in the emergency brake, etc. I need to think about those things. But the fact is, I can't also be skeptical at the same time. That's just the way the world is. Actually, when I told you I got married, it wasn't entirely an irrational decision. So, for example, we did all kinds of marriage counseling with wise people that try to give us advice. We did we asked friends to give us advice. We kind of got to know each other and saw whether we enjoyed being together. We even did a compatibility test, where you have to fill out all these little multiple choice things and questions about where do you squeeze the toothpaste, the middle or the end. We and I just have two separate toothpastes that work much better. But you don't marry somebody because you score 95% on the compatibility test, right? But what this tells you is there are rational, thoughtful ways to find a marriage partner, and there are irrational ways. If I go out on the street, grab the first best woman I see and say, please marry me, that would be irrational. If she says yes, that would be scary, or maybe scary both ways. And so we realize that's not the right way. We've learned rational ways of doing it, but science, the scientific method is not the right way of doing it. There are, just like in faith, there are rational ways of thinking about our faith and believing things and weighing evidence, but there are aspects of what we understand about God that are only accessible to us when we've made steps of faith. So let me look at a few other examples of where science and faith sometimes can get confused. So science can feel sometimes overpowering, or the idea that one day science will someday overpower all other ways of thinking. But I think a lot of those are zombie myths. So let me give you another example, which you see a lot in popular science writing. And I'll give you, let's say you come to my house and you ask me, why is the water boiling? And I say to you, the water is boiling because the heat source that transfers thermal energy across the container wall into the liquid. The mean square velocity of the fluid molecules, which is directly proportional to temperature, goes up. When that temperature reaches 100 degrees Celsius, there's a phase transition from a condensed phase to an expanded phase, which we call boiling, and that's why the water's boiling. Right? Now that's a perfectly good answer on one of my thermodynamic tests. But you could also come into my house and say, why is the water boiling? I say, oh, I fancy a cup of tea. Would you like some? And the point is, those are two complementary explanations for why the water is boiling. One doesn't exclude the other. There are just multiple ways of thinking about that. And if you want to read more about that, I really recommend the British philosopher Mary Midgley, who writes on multiple maps of reality. There are just many different ways of looking at the world around us. And just because I've explained to you scientifically why the water boils does not mean that I've explained everything away. So the understanding a mechanism of something does not exhaust other ways of thinking about it, including ways that are rich in meaning. Here's another one of my favorite zombie myths. I call it nothing buttery. So here is a classic example from the great Cambridge scientist who wasn't Cambridge, was Francis Crick, who decoded with Watson and Crick the DNA. And in this book, The Astonishing Hypothesis, he says, your joys, your sorrows, your memories, and your ambitions, your sense of personal identity and free will are, in fact, no more than, I call that nothing but the behavior of a vast assembly of nerve cells and their associated molecules. And he's basically saying, he moving the neuroscience nature of his life, he's saying neuroscience will explain everything about you and your identity. I call it nothing buttery because I can do this little argument with many different levels of explanation. So I could say, I am nothing but a bag of chemicals. Humans are nothing but collections of chemicals. And if I were to go back to an earlier version of myself, when I was first courting my wife, Mary, and things were starting to heat up a little bit, I'm thinking, ooh, this is going well, okay. There was a point where she basically asked me a question along the lines of, how well do you know me now? And every man knows that's a very dangerous question. you better get it right or you're in trouble. Right? And but let's say that I panicked. Okay, I say I'm a scientist. I know what you are. You're a collection of chemicals, about enough phosphorus for 2,000 matches, enough iron for 1 nail, enough chlorine to detect a swimming pool, and then I really blew it. Enough fat for 10 bars of soap, and that would be basically the end. Even if I said 1 bar of soap would be the end, because we all see this as nonsense, right? But it's true. My wife is a bag of chemicals. I'm a bag of chemicals, okay? But I'm not nothing but a bag of chemicals. That was a strange way of thinking about myself. And so if we take this further, I can think about many other things about myself. What am I? Who am I really? Well, I am an animal. Here you can see the description of I am all from kingdom down to species. It's all true, right? I'm a mammal, right? Mammalia, I'm a primate, etc. I'm a chordate. All those things are true. Right? But it's not nothing but. I'm many other things. Who am I? I'm also a self-assembled biological machine. I'm a product of my genes. I'm a product of evolution. I'm a member of a social system. I'm gendered. I'm a citizen. I'm an economic actor. All these things are true about me. Right? They're all true at the same time. Right? And just because I say to you, you are nothing but an economic actor, right? It's actually nonsense, right? You are nothing but the assemble of nerve cells. It's kind of nonsense because all these things are true. There are multiple maps of reality. And understanding one mechanism of how something works does not exhaust all the different ways that I might think about myself. And if you are a religious person like I am, then I have a lot of other I ams that are related to what I think my religious identity tells me who I am. So in the Christian tradition, I would say I am a child of God. I am loved by God, and my value comes from that fact. It's also true. All this can be true at the same time. I'm a father, actually. That's how I feel. If you ask me who I am, my first answer might be that. Because right now, it's just an amazing experience to be a father. And I was just visiting my friend Carl, who's a new father. And Carl has changed from being this to that. And that's a very, very big change. And you're looking mighty awake for a young father. So good, well done. So those are the kind of zombie myths about science and religion. Now, religious people also have their own misinterpretation of science. And my favorite one is this one, called God of the Gaps. Here's a little cartoon. I think should be more explicit here in this step 2, where a miracle occurs. And of course, I can't prove something, my student can't prove something, and it says a miracle occurs when they go from A to B, you get a low grade on my exams. But the idea of God of the Gaps is quite pervasive, both religious people and non-religious people. And the idea is, if there's something we can't explain, then that's where God fits in. So I'll give you an example in my own life. It happened to me several times. I come to a church, somebody says to me, they see me there, and they say, are you a scientist? They kind of look afraid. They say, isn't it amazing that we don't know why or how birds can fly many thousands of miles and land in exactly the same location as where they were first born? Isn't that amazing? Which is basically how they migrate. And I think I'm usually kind of saying, oh, that's how interesting, but I think that's basically God of the gaps. I'm trying to find God in this gap in my explanation. I think it'd be wonderful if we could figure out exactly how birds migrate. And actually, one of my colleagues in Oxford Chemistry has worked out that some really cool stuff about quantum processes in the brain that may help with following magnetic fields. So it's all very cool, and that's really exciting. And it doesn't make God less. It just, because what's happening in God of the Gaps is actually a kind of mechanism of meaning confusion, that if we understand the mechanism of something, then God has somehow gone out of that. And good theological thinkers have argued against God of the Gaps for a very long time. Here's one of my favorites, because he was the first Oxford professor of theoretical chemistry, and I used to be a theoretical chemist for a number of years when I was in Cambridge, in fact, before I went to Oxford, installed late and became a physicist again. But Charles Coulson, one of the great fathers of chemistry, said this God of the Gaps, putting God into a little gap in our knowledge, is a fatal step to take. It's to assert that you can plant some kind of hedge in the country of the mind to mark the boundary where a transfer of authority takes place. So either God is in the whole of nature with no gaps, or he's not there at all. So for somebody who is religious, I think in the deeper parts of the Christian tradition, for example, we believe that God is part of everything that we study. And we don't find more of God by finding a gap. That's just the wrong way of thinking about it. It's very pervasive. It goes both ways. So there can be a kind of atheism of the gaps, where you basically say, I don't understand something about the way the world works, therefore this tells me that there is no God. And that's also a kind of, or if you can also say, I've filled the gap, and therefore God has disappeared and there's no God. So the idea that God, is true, by the way, that people used to believe that gods were doing all kinds of stuff. The gods were moving the stars around, the gods were causing thunder and lightning, and over time that's dissipated away. Okay? So historically that has happened. But a lot of that was linked to all kinds of superstitious ideas. And we still have a lot of superstitious ideas of this nature in our cultures. But I think those are not very well thought through ways of thinking about the world. And a good, deep theological understanding of the world would give something, an argument on God of the gaps. Right, my last zombie myth, or the seventh one anyway, is that science is the best avenue to truth about ultimate questions. The one I kind of started with, saying science has given us all this amazing advancement. Surely it'll answer the really important questions of life. And here's my colleague Peter Atkins, also a chemist, who I really enjoy interacting with, but I disagree with almost everything. He said, there is no reason to expect that science cannot deal with any aspect of existence. Although poets may aspire to understanding, their talents are more akin to entertaining self-deception. Philosophers, too, I'm afraid, have contributed to the understanding of the universe a little more than poets. I apologize to poets, by the way. I long for immortality, but I know that my only hope of achieving it is through science and medicine, not through sentiment and its subsets, art and theology. So this is, I picked this because Professor Atkins, a very famous chemist, you may have used his textbooks if you study chemistry, is giving here what I call scientism, the idea that science is the only avenue of truth and explains everything. And what you quickly see with scientism is that it starts to erode away not only faith, but also many other parts of our lives that we consider to be valuable and interesting, because it says there's nothing but science, and therefore all these other things are eroded away. And there's something kind of weird about it, right? And something that seems just reductio ad absurdum odd. But it's a consistent view. If you really believe there's nothing but atoms and molecules, you kind of end up in this direction quite easily. I'm going to contrast that with another Oxford professor, Prina Medawar. Prina Medawar was a Nobel Prize winner in medicine, and he wrote, and an atheist, but he wrote this book called The Limits of Science. I'll take two quotes from. Science is a great and glorious enterprise, the most successful, I argue, that human beings have ever engaged in. To reproach it for its inability to answer all the questions we would like to put to it is no more sensible than to reproach a railway locomotive for not flying, or in general not performing any other operation which it was not designed. So what does he mean by that? He says that there is indeed a limit upon science is made very likely by the existence of questions that science cannot answer, and that no conceivable advance of science would empower it to answer. These are the questions that children ask, the ultimate questions of Karl Popper. Popper's a philosopher, famous philosopher. But I could say the ultimate questions. I have in mind such questions as how did everything begin, which he doesn't mean the Big Bang, but where did the laws of nature come from? What are we all here for? What's the point of living? It's not the science, therefore, but the metaphysics, imaginative literature, including poetry, or religion that we must turn to for answers to questions having to do with first and last things. So two Oxford scientists, two very contrasting views of where these big questions come from. And no surprise, I'm siding with Peter Medawar here. And I actually think that Peter Medawar's points here should be completely uncontroversial. I think everybody, atheist or non-atheist, should more or less believe that this is true. I think it's not that hard to show. So I'll give you, rather than arguing this tightly or carefully, I'm just going to give you a really simple way of thinking about this, of illustrating it. Let's say you want to measure the value of the human life. You want to use science to say, why are human beings valuable? Now, I hope people in this audience believe that humans have intrinsic value. In other words, their value is not linked to whether they're rich or poor, what race they are, what gender they are, where they were born, all those kinds of things. We believe that humans have intrinsic value that's not linked to these physical characteristics. Our human rights, our ideas of human rights are one way of trying to codify that intuition. But it's incredibly important for the way our society works. But how would you use science to answer that question? Well, I'm going to be facetious here. Let's say I'm a chemist, okay? I could measure the value of the elements in your body, okay? And I could decompose you, and your bag of chemicals is true. And if you have gold fillings, you're worth more than something. Well, that seems silly, right? You can't be worth, that's kind of crazy. That doesn't work, okay? That's not the right way of thinking about it. Now, physiology, I can measure how big your brain is, okay? If you're a big brain, maybe you're worth, but that doesn't make a lot of sense. In fact, really, the brain size doesn't correlate with many things, except big heads. A psychologist could be how smart you are, how intelligent you are. You have to make tests, and then but that seems kind of dystopian. An anthropologist, how does a community value you? How do they think about you? But that again seems a strange way of giving value to human beings. An economist, I can see how much economic value do you produce. I sometimes worry that our government overlords mainly care about this in our lives. But we all sense that these are the wrong directions to take. And so no conceivable advance of science is going to answer this question, because fundamentally it's a value-laden, it's a philosophical question, it's a theological question. It's a very important question. It's not one we can shy away from and ignore, but it's also not one that science is going to answer for us. Science can help us on the edges of it. Science can help us maybe sharpen the questions and can do all kinds of helpful things, but it can't ultimately answer this fundamental question. In the Christian tradition, the idea of individual human value is deeply linked to the idea that humans are created and loved by God. This had a dramatic impact on a radical change from the ancient civilizations, Greek and Roman, for whom the idea of humans having intrinsic value independent of say, how they were born was crazy. You had slaves and free and citizens. They were completely different. Men were much better than women. All these things were just natural part of the culture. So historically, this idea had a huge impact on how we now value human beings, the Christian ideas. But you could say, well, that was accidental that happened. It just happens to be true. My grandparents, I mentioned my grandparents were very staunch humanists in the Netherlands. So humanists believe that humans have intrinsic value, but they're also very staunch atheists at the same time. Those things are put together. So I used to ask my grandfather, so why do you believe that humans have intrinsic value? And he'd say, that's just a brute fact, okay? That's just true. It's not something, don't argue about that. It's just true. It's a perfectly consistent and plausible position. I don't personally find it very intellectually satisfying, but I'd much rather you have that than that you say, I don't believe anything except the laws of nature, and therefore humans don't have value. And there are other ways you could say. So my grandfather would say, yes, historically it had some Christian roots, but now we know it is true irrespective of Christianity. It's also a perfectly valid thing to argue. We can argue about it. But the point is, this is a really important idea, and where it comes from is difficult. So at the end of the day, we're all philosophers or theologians, and science has actually very little to say about almost any of the big ultimate questions. We have to get answers for them from other ways of knowing. Another way to think about this is to say, that doesn't mean that there are these easy questions. So here are some zombie myths, right? So they're the simple but wrong answers, like faith is the great cop-out, right? Science is all about rationality, faith is about irrationality. It's kind of nonsense, actually. You really shouldn't be able to say those kinds of things in public, but people do. And complex but correct ideas are very difficult to get to in these ultimate questions. So I think this should be basically uncontroversial. What is very controversial, maybe, is how I answer my ultimate questions, and you may disagree with me very strongly, but the idea that science or scientific methods are going to answer these ultimate questions is wrong. Science can hugely help me formulate those questions and sharpen them and think about them more clearly, but it's not going to answer those fundamental questions of value and meaning and purpose, because they're a different type of question, and no conceivable advance of science is going to answer them. For the last 5 minutes, I want to just ask myself some bigger questions about what this means in our university. So I talked about soft scientism at the beginning, which I define as a vague idea that science or some kind of scientific method is going to eventually overturn all the other methods that we use, and it's going to bring us progress, and progress is going to continue on. We put superstition behind us, and now we're progressing, and we're on the right side of history, and we're moving forward. And this myth can be of an inevitable progress of science. Scientism can be hard. In the Peter Atkins one, where you say there's nothing but science, and even poetry is nonsense. That's actually more rare, because it's kind of weird. And people don't really live their lives that way. Even Peter Atkins doesn't live his life that way. He's got a beautiful piano in his home that self-plays, and he loves music. So he's like, oh, this stuff doesn't make any sense. It can also be, I think it's the soft scientism, which is much more pervasive and much harder to argue against. It's kind of unspoken. It's there in the background in our public spaces. I think it pervades the modern, in the West particularly, the public sphere. And it actually ends up eroding our ability to have hard but necessary conversations about ultimate questions. And this affects humanities too. I think of lost a lot of their confidence in looking at these ultimate questions. So part of what Peter Medawar says is one of the ways you look at ultimate questions is through basically the humanities. And the humanities a lot of them have kind of given up on looking at those ultimate questions. And I think one of the reasons is because a soft scientism in the background makes them think that they're never going to really do it. Science is going to do it for them. And they're waiting for the inevitable progress of science to overwhelm these big questions. So they're working on little things on the side. There's another reason, which I think is also pretty legitimate, which is that it's hard to talk about these ultimate questions. We really disagree about them. And people with religious convictions can be very difficult to argue with, and they can be very stubborn and not open to rational arguments. Those are also reasons why maybe in the humanities we kind of get away from those things and do something that's a little bit, hopefully, more neutral. But I think fundamentally it's a soft scientism that has eroded their confidence. And I think a soft scientism, even worse, I see that even in my own university, as funding models start driving more and more what we do in the university, since more funding comes to certain parts like the sciences, we keep expanding. The humanities have a hard time attracting funding and they shrink. And because we don't really see why they're valuable, because we think that soft scientism, where eventually we're going to understand everything, it is really bad for humanities. Even if you're an atheist and you should care about this, if you care about the soft scientism, it's actually eroding our ability to do stuff. And this soft scientism also, by definition, excludes religious voices, because religious voices are in that category of ultimate truth claims, which we don't really believe we can do anymore. And religious voices are even perhaps dangerous because they undermine the soft scientism that's there in the background. And I can broaden this a bit further. So my friend Tyler Vanderveel at Harvard I was at a lecture recently, I took his slides because I liked his sense of the secular. So we think of university as secular. I think Hong Kong University is a secular university. Most universities are secular university. And there's really two ways in the Oxford English Dictionary, which we just call OED. One is that one that explicitly excludes religious perspectives. So the OED pertaining to or accepting the doctrine of secularism, e.g. religious considerations, should be excluded from civil affairs, moral reasoning, or public education. And that is often effectively what we see in our university. They just say, no, you can have religious thinking in a little silo, but you can't bring religious thinking into your humanities course, for example, as a valid way of thinking. Let's think about what it means to be a human being. You might say, I think human beings have intrinsic value. That's fine, but you have to keep, that's a private view you keep outside. Okay? You can't bring that into a discussion on social ethics or economics or politics or anything. Where actually, that should be a valid, a lot of people believe it's true, right? It has a big impact on how we might do some of our work or think about our work, but we're afraid to bring that in. And a much better secularism might be one that doesn't impose any religious presuppositions or perspectives. So not concerned with, as the other definition that the OED gives, not concerned with or devoted to the service of religion, not sacred. And actually the first one, which is become almost dominant in our kind of secular universities, actually makes all kinds of really strong epistemological assumptions. It assumes a commitment. So it basically assumes that the only way of getting knowledge is by these kinds of quite a restricted way. Actually, a soft scientism is what's lying behind it. And I think it's just not good because it's not bringing us to truth. And I think there's an ideal that we might have of a more open university, which might be defined as one that's committed to open inquiry principles, namely that every idea and perspective is welcome, okay, but requires rational exposition, engagement, and defense. And every idea and perspective is open to rational critique. This is from Tyler again. So this is also important this should include religious perspectives, okay? And I think the thing which we've not really learned how to do as secular universities is how to include religious perspectives in a way that they themselves are also open to rigorous critique. Religious people can be very sensitive about rigorous critique. They may not like rigorous critique, and so they might pull away from it, or they might become very rigid in their thinking about these things. And I think any good religious perspective should be able to be open to critique. One of the ways that you can think about whether a religion view has value is asking what does it imply for the big questions of life. Does it seem reasonable? Does it make sense? Does it connect to the other things that we know? I think it's really important for religious people to look at the advances of science and ask themselves, are these consistent with my religious beliefs? Because if they're not, they have to think really hard about whether they've either misinterpreted their religious beliefs or whether their religious beliefs might be wrong. And so there's a lot of work to do. Okay, I think before we can do this, but I think an ideal of an open university would include a much more clear idea about what you do and don't allow. And I think in that space, there'll be a lot more space for religious perspectives. And in order to get there, we must slay the zombies, and we must also face our fears. With that, I thank you very much.
Thank you, Art, so much for slaying the zombies for us. Please have a seat, and we have some time for questions. Wow, you did a good job of zombie slaying. I hope they don't, do that thing. Anyway, we have some half an hour for questions. As always, with the Faith and Global Engagement lecture, we have 3 rules, A, B, and C. A is please be articulate. Please prepare your questions beforehand. Don't make it up as you go along. And make sure you have a mic before you ask your question so we can hear your question. B is please be brief. A lot of people ask questions, like to ask really long questions because they're not really asking a question. They're just trying to make a long statement because we're all professors and academics and we love to hold forth. But please don't do that. Please make your question short, sweet, and brief. And finally, C, please be centered. Please focus on the issues that were raised today in the lecture. So those are the 3 rules. So are there questions? Please, let's have some. Please raise your hand, and we have some mics around to do that. Okay, so there's a question here at the front. And was there another question? Okay, let's have this one. Any other question? Okay, let's have this one question first. Please introduce yourself and ask your question.
I'm Kai. I'm a third-year math student at UCL. I was wondering, because you said about how you think that these myths keep coming back up again. How do you think it would affect society if somehow we could just have everyone, not believe them?
In the myths?
Yeah.
That's a good question. So be very careful with my answer because I'm a physicist. And you're asking a question about society. That's far outside it's very, very far outside of my expertise. What I do think is, I'll look at the world I understand a little bit better, which is the world of universities. And I think that it would be good for us to have a more robust engagement with religious ideas in universities and take them seriously and ask ourselves, what do they mean? Now, in maths, I don't think it will have a big impact on how you do your proofs. Okay? But in the humanities, it might have an impact on what you might study or what things you might give your students to do and what questions you might ask them. And in the social sciences, it'll have the idea of what a human being is lies at the core of many of our studies in social sciences. And it's better to have those things explicit and have us all agree about that we make clear what we assume. So if you assume that there's nothing but atoms and molecules and that human beings don't really have intrinsic value, for example, you should say that at the beginning of your work. And I will look at your work and I'll know that that's the background that you come from. And it'll help me understand why you come to conclusions that you do. So I think being open about the kind of presuppositions we have is really important. Maybe last thing I'd say is that what the self-scientism does is it makes a lot of assumptions implicit and not explicit. So you don't really realize that these assumptions are folded into a discipline when it would be really helpful to know that they're folded in. And people who are then engaged in those don't even realize that they are making assumptions that might not necessarily be obviously true.
It might help also to make our university more integrated so that people are kind of crossing faculties more, right? So the mathematician may not affect the maths, but they would be interested in doing stuff in the social sciences and humanities, right?
Yeah, exactly. So I think that another thing, I think the kind of siloing of our fields is also linked to linked to this idea that it's not really enriching for you to go and talk to people in a completely different discipline, but it is enriching. And I think that it would be better for us in that way.
Yeah, other questions? There's a question there and a question there. So maybe there's a lady there. Yeah.
Hi, thank you. My name is Amrut. I'm an astrophysicist.
Oh, good.
So kind of similar. I just wanted to ask about this concept of an open university. Let's say the university agrees to open inquiry principles, but if I wanted to research on something, the grants committee and therefore the government also needs to agree on what they think is good research.
Yeah.
So what do you think is the best way to change the system so that people are willing in the university to ask these questions, but they're limited because, for example, in Hong Kong, the RGC doesn't think it's worth pursuing. So the system would need to change, right?
That's a good question. So one thing, so you're a scientist, I'm a scientist. For those who are not scientists, we spend a lot of our time writing grants and asking for money, right? Your tax money, so thank you very much. But we can't just take it, right? We have to compete with each other. And so you and I might be competing for grants, and I want to grant on something, and there are then committees that will decide who gets it. And sometimes the decisions are based on the hope of economic outputs. So if I work on something more applied, I'll get more likely money than you working in astrophysics. Those are moral questions are being, there's a question, what's the value of knowledge, right? And if you're doing astrophysics, a lot of that is not applied, right? So here's an interesting thing that I think would change. So right now, we all lie on our grant applications, okay? We basically say, oh, this work I'm going to do for you, this new science, is going to help cure cancer. Or if I do this big new astrophysics thing, there's going to be a spin-off, like Teflon came out of the space program, right? And so that's why we're doing it. And that's how we try to convince our government overlords who are interested in economic outputs on why they should fund it. We all know that we'd love this to happen, but that's not why we're doing it. We're doing it because we love it, because it's beautiful. We should just tell them we do it because we love it and it's beautiful. And they should decide among all of us who want to do this, what is the right thing. It's still going to be hard to decide, but at least we're honest about it. And so I think there's many, many examples of that in our system now where we're actually lying to one another about what we really care about. And it'd be better if we just were honest. That's one example of how that works. There are much more complicated. I think this idea of open university, you would need to experiment with how that works as you open up to broad ideas. The first step, and I didn't flesh this out very much because it's at the end of my talk, just like I'm trying to provoke some thinking, but one of the main ideas, as I said before, is part of the openness is also everybody recognizing that they have a certain set of assumptions that they're taking with them to the table, and they should be open about those and clear about them, and honest about them. And that, so by the way, just to say, applied research is also very valuable if it's directly applied, and you're actually doing it because you want to do some applications, it's also very valuable. But for those of us and I'm assuming you're not an applied scientist because you're an astrophysicist, and I'm not an applied scientist, I'm a theoretical physicist. If you ask me why do I do the things I do, I think because they're beautiful and interesting, and I think they're valuable, and I think maybe one day they will be applied, but that's not why I do them, although I'm happy if they're applied. But that's not my motivation, and so I have to pretend like I am because I have to fill out all these boxes that tell me what the economic output is going to be. I know that I actually can't make that happen as much as I want to, and so I just pretend. And the people who read it on the other side, they all know that, and we all do this.
Yeah, it's interesting because basically you're arguing for the intrinsic value of knowledge, which obviously universities should be interested in. Somehow we've kind of lost that, in our sort of economic drivers.
I think the interesting thing is people at universities are interested in intrinsic knowledge.
Yes.
They just pretend that they're not in order to get funding, and the funders actually kind of know that too, and it goes back and forth. And and one of the reasons actually you could take a pragmatic view, which is that many of our most important transformative discoveries came out of work that didn't seem to be applicable. I'll give you one example. So right now AI is very hot. It's based on a technique called neural networks. One of the great founders, Geoffrey Hinton, who got both the Turing Prize, which is the big prize for computer science, and the Nobel Prize in physics, interestingly, although he's a computer scientist. In 2012 was when he did a very famous paper that got the whole thing going, which is what now we're seeing everywhere. Created trillions of dollars of value. Just before that, he got a review from one of the conferences that said, why is Hinton still working on this? Everybody knows he's not going anywhere. He should stop and do something more interesting. Okay. So one of the reasons why we do intrinsic knowledge and think for the sake of, and why we have a portfolio of ideas is because it's really hard to predict what's going to pan out. Right? And so just on that basis, the government should be funding a wide spectrum of out-of-the-box ideas, blue sky research, because you never know when something transformative is going to come out. There are other ideas that probably got the same referee kind of report that Hinton got, and that ended up actually not really going anywhere. Right? And you just don't know. Right? So part of this is also, we should just be honest about the fact that we don't always know what's going to happen. But we need that diversity of views, including views that we think are crazy, like neural networks are going to be any use of any kind whatsoever, right? Which now seems insane that anybody ever thought that, but that was a dominant view for a long time. And people like Hinton were just pig-headed enough to keep going, right? And so that's great. And I think that kind of viewpoint diversity is important for outside of the sciences in other fields as well. There are ideas that just seem kind of strange and weird, including religious ideas that maybe turn out to be really valuable at some later stage. And we should encourage that in an open university.
There's a question here. Yeah. Hi.
I'm Tasha. I'm a history and English student here at HKU. So you mentioned the idea of the flying teapot and the burden to prove, basically, right? It's on the person who is believing in a certain thing instead of the person who doesn't believe in a certain thing. And then you mentioned that God, he, at least per traditional theology, is the reason for the universe, etc. But I guess what I'm asking for is clarifications on how that fact kind of impacts the logic that the burden to prove is still on the person who believes rather than the person who doesn't believe.
Yeah, thank you. I think I probably didn't explain that as clearly as I could. That's a great question. So I call it the asymmetry argument. The asymmetry argument says, I don't have to make an argument for why there is no God. Okay, that's just the assumption that's just natural. God is an unnatural assumption that you need to give me evidence for. Just like if I claim that this water is some kind of amazing thing that will make you live 150 years, you need evidence before you believe it. Or any other crazy idea that you have, or even a true idea that I think, but I need to show you evidence. And that's the asymmetry. The idea is that somehow the default that you shouldn't, that if you don't believe God, you don't need to give evidence for it. And what I'm saying is that's just not the right way of thinking about it. I think either there's a God or there's not a God are two different brute facts, two ways you can start. They're like priors that you might have, right? And then given that prior, you can look at accumulating evidence and whether that increases your likelihood that one of those two things is true. I've had more time. You can talk about this in more formal Bayesian ways. But effectively, the way it works is, if I want to find evidence for God, I can't assume there is no God, and then try to find evidence for God, because I've already assumed away the thing that I'm trying to find. I need to assume there is a God and then look at the world and ask myself, does that make more sense of the world than if I take the opposite view, there is no God, and look at the world? So let me give you one example. So science is based on a bunch of assumptions. And one of the assumptions is that the world is uniform. So if I do an experiment in Oxford that somebody in Cambridge under exactly the same conditions, if they're smart, will get the same results. Okay? And that idea that the world is uniform is not obvious to people. So I grew up in Gabon in Central Africa, in a kind of a jungle area, where people's experience of the world was that the nature is capricious. Nature changes, nature does all kinds of weird stuff. Why would it ever be the same all the time? And for most of history, that's how people thought about the natural world. If you look historically, the idea that the world is uniform, so that you do the same thing under the same conditions, you get the same results, is deeply linked historically to Christian thinking about a God behind the world that creates that kind of, that sustains the world and therefore would do the same thing in different locations. Now we think it's obvious, or maybe we think it's been proven a posteriori because it's been successful, but it's not obvious. The fact that the world is regular is kind of surprising, right? On atheism, why would the world be regular? Why would the world not be irregular? Why would the world not be chaotic, right? On theism, it's maybe not surprising that the world is regular. And so you can go with your arguments, but you've got to start from one starting point or the standing point and then look at the world. And my point is, if you say that there's an asymmetry, that somehow not believing in God is the natural default, you've actually made a whole bunch of assumptions that I think are incorrect about how the argument should run. And you smuggled in a whole bunch of assumptions about the way the world is, or the way God is, that are just incorrect. And you're not thinking about it rationally. It's a much longer argument we could have, but the first order, that's what John Booking was trying to say there, that the asymmetry is the wrong way of thinking about things.
So keep things symmetrical, like in your research.
Symmetry,
it's good. Your new laws of nature also works for this one. Yes. Other questions? There's one question there and one question here as well. Any more? Okay. The gentleman in the polo shirt in the middle. Yeah.
Thank you. My name's Andy Green. I've been working in neural networks since 1986. And I can remember when I was asked by my vice chancellor whether this was an appropriate area to concentrate.
Okay. So you're also one of the brave ones that kept going.
So I was interested in your comment about blue sky research. Do you think in a perverse way, soft scientism actually is damaging science, let alone our view across the whole world? Because in my area, we're starting to look at the issues of consciousness. I've come across a number of researchers who are working in near-death experiences, and they have found that they have wandered off the path sufficiently for them to be no longer considered part of the flock.
Yeah. Well, so I think that's a super interesting question about whether the soft scientist limits us from certain more slightly out of the box ideas like near-death experiences or consciousness. And I think we should be much more friendly to those ideas. And I think part of what drives the putting them out of the flock is a fear of religious ideas coming in. And some of that fear is justified because sometimes religious people want to close down certain avenues of research as well. And so, but a lot of it is actually about power. And you're asserting power and you want to keep the religious people out. And so when somebody starts to stray in a slightly odd way, even though I might think that's a crazy idea, I think they should be allowed to, if they can justify it and do careful experiments, I think they should do it. And we should be open to the truth no matter where it leads. And there's those are examples of aspects of our work that hold us back. But I think there's a deeper problem, which is the soft scientism often pulls us a little bit away from work that's just intrinsically interesting towards work that has to have a derived value. And I think that works in a more subtle way. And I think that applied research is super important. We should do it, and it's very important. But I think it drives us in ways that are not. It can drive us away from kind of diversity of views that we'd have. I think so. What I'm saying about that is that here's a sociological way that works. So, as you probably know, if you work in neural networks, there were also even in that field there were everybody worked in one direction. Now they all went the other direction. And so this kind of swings back and forth, and things are in vogue. And I'll sometimes say to my students, they'll say, "Oh, we should do this way because that's what gets published in Science or Nature or whatever the physical review that's a really big journal is." And I always pull my hair out because I think you shouldn't work on something because it's popular. You should work on something because it's interesting. But it's becoming more and more so in our fields that basically there's a herd mentality that happens. And I think that herd mentality happens precisely because we're not used to fostering the kind of viewpoint diversity that we need. And so that because we're not used to that, because we're not trained in, wait, why don't we think differently? Why don't we think differently about it? We start thinking like everybody else, and we get the herd mentality, which limits our science. So there's been really good studies that have shown that research groups who have a lot of interaction with each other, over time, start to become less creative. And the reason is they all start basically believing the same things and holding on to those things. There's a herd mentality, just a natural aspect of how humans are. And so we should fight against that by saying, no, you should you should bring people in that are different from you, that think differently, and allow that viewpoint diversity to happen. I was talking to a friend actually on Thursday, who's a neuroscientist. She was just at a neuroscience conference in Oxford, said it was difficult because there are two big people in the field who are fighting each other, and it was really hard to make any progress because they basically squash everybody that thinks differently from them. And so those are the kind of, as you're all nodding because you know that as a scientist that this happens. But I think it's inevitable that happens to some extent. But I think that the lack of openness and the lack of explicit valuing of viewpoint diversity makes that much easier to happen and makes science less creative and less interesting.
Thank you. I think there's a question here. Is that right? Yeah.
Thank you so much. I appreciate your time. I just want to clarify. Did you say there are more Christians in science, natural science, than in humanities and social sciences?
So in the universities where I have been, that's been almost always the case, and sometimes by some large. These are Western universities, so I have no idea what it's like in China or.
I think engineering here have a lot of Christians, and the humanities we're just hopeless. Okay. Yeah, we're just like we don't believe in anything. Yeah,
that's just an empirical observation.
Yeah. And the book you mentioned, the study on 8 regions. And what did they say? I mean, is this very universal or?
So this is work by Elaine Howard-Ekelund. So she studied 20,000 scientists, and she interviewed them. So she did not study. People often ask her, why don't you go back and do it for social scientists and do it for humanities people and look how it's different.
Yeah.
And she says, if you give me the funding, I will.
And what's your speculation, the reason why there are more vegetarian butchers?
Yeah, exactly. Maybe I would say, I don't really know exactly why. So I talked to Elaine, the woman who did that study about it, and she says she thinks it's empirically also. She thinks it's true, but she's a good sociologist, won't say anything about it until she actually measures it, which is I think a good idea. So take my words. The fact that she won't speak out on it means you should take my words with a grain of salt. But she thinks one very strong factor is that people with religious convictions often feel embattled in these fields, like the humanities or the social sciences, more so than they feel in the sciences. And so they tend to move out to leave academia and do other things. And so it's like a pre-selection. In fact, that might play a role. Why is that the case? Well, I think it's because the humanities and social sciences do make pretty strong theological and philosophical assumptions in their work. They're often they're not explicit, they're implicit. Okay? And if you come in and you challenge those implicit assumptions, people get very nervous because they're not used to that viewpoint diversity. And they're actually not even used to often articulating what their views are. They just hold them very strongly. In the sciences, that's also true, okay? But it's often not about the science itself, but about other subjects. And that's why it's just much easier to be a Christian in the scientific field. That's my kind of idea of it. So it's easier because it's easier because unfortunately your religious views are less interesting for your actual work than they would be if you're in the humanities or in the social sciences. Because if I'm a theoretical physicist, either my equations are correct or they're incorrect. And that's largely independent of my other beliefs. In fact, for a theoretical physicist, being a little eccentric and having crazy ideas is part of the package. Right? And so if I have crazy ideas, my colleagues say, yeah, of course he has great. That's good, right? He's like a little crazy. That's good.
Yeah, no, I also think quantum physics is completely crazy. If you could believe that, you could believe in anything. Anyway, so are there other questions? Yeah, there's a question back there from the gentleman in the black. Any more?
Thank you, Professor. And I'm a student here at HKU, and I study philosophy. And I think those ultimate questions do need science to answer. For example, the classical man and body problem. Do we believe in dualism, or our mental status are also physical, and our thoughts, our feelings are the movements of those particles? And if this is true, we may not have free will, and we are subject to determinism.
So I'm familiar with those debates, right? So the idea would be, if our minds are nothing but neurons, then, for example, does that mean that which are deterministic processes with some stochastic elements in them, but fundamentally maybe deterministic at some level or stochastic at some level? Is that all that we are? I don't believe that's true. Okay, I don't believe that we're subject to that kind of determinism. I think it's hard to exactly explain why. Maybe there's some kind of strong emergence that separates it out from the underlying substrate. I lean towards dualism, but my philosophy friends tell me that's a bad idea, but I think it's probably true. But that's why I'm not a philosopher.
Yeah, dualism. Yeah, we should ask the philosophers over there.
But, they were looking at me.
We should.
Yeah.
There's a question there from the gentleman.
I was just wondering whether that idea on the board of rational exposition and rational critique in an open university is actually tenable, given how different disciplines' methods are, and how can it be universally agreed upon? What is a rational?
Exactly. So I think that's an excellent question. So one of the reasons we don't do it is because people are worried that it's not doable. Right? That's why I ended with we should face our fears, right? Because we're afraid that we're going to get into fights with each other. But what happens instead is that we still have various kinds of ideas about these ultimate questions that we impose on others without even realizing that we impose them. So in my own discipline, scientists, so right now scientists, if you have a lot of cultural power, and so scientists sometimes stand up and say things. I say they wrap themselves in the mental science and then pronounce on ultimate questions and pretend like science has something to do with those things, but it doesn't. Right? What they really end up pronouncing on is their own personal preferences or the ideas that they got from their background or happen to be popular in North Oxford, where they happen to live, for example, and they pronounce on those as if those are true. And people think that because they're scientists, that somehow science has spoken along those lines, but it hasn't. And so it'd be much better if they would be more open of where their ideas come from and at least recognize that those ideas might not be true, or there might be other ways of thinking about it. So I think your question is a super interesting one, because how you would do that and do that well is a difficult question, but I think we need to.
One thing we talk about, we did the Life Worth Living class today, and one of the principles that, in fact, Jonathan came up with, Jonathan Johnson over there, is that we have 4 C's, right? So we begin with curiosity, right? And then we go into charity, and then we get to critique. So in a way, critique comes a little bit later, and then we move into creativity. So I think reducing it just to critique may be a little bit too drastic, maybe. So there may be a whole bunch of other stuff there that also can help that discussion to move in positive or constructive ways, right? Because critique can be quite devastating, especially in the humanities. We're really good at critique.
So I'll add something to that. So actually, one thing over the last few years, I've been doing a little bit of work in philosophy, and so I've given a few talks in our local philosophy department. The first time I gave a talk. So in physics, you give a talk, people raise their hands, what about this, what about that? They ask questions all the way through, okay? Nobody asked any questions, okay? So I thought, but they seem to be paying attention. So I finished my talk, and then they stopped, and they went for some break, and then they came back for like an hour and a half of questions, okay? And then they came with the questions, okay? But then the first thing that they did is then they would summarize what I said better than I said. I thought, they really like it. And they would say, but, they would say, and then they would criticize it. And I liked that. I thought, it's really nice part of that subgroup, like those that culture where you first try to explain the other person's argument better than they did themselves to show that you've really understood it, and then you say where you object to it. And I like that. I think so it doesn't always work that well in philosophy, but as a discipline, it has that as one of its core. And I think I'm trying to take that into my science. Sometimes if I see something I don't really understand or believe in scientifically, I try to at least explain why the person might have believed it and then give my criticism. I think that's the first thing.
The quality of critique is important, I think. Yeah, absolutely.
But you have to understand other people's views well, and that can be difficult to do. It can also be very revealing if you watch people disagreeing. If the other person cannot articulate their opponent's view well, that's never a good sign.
Now, we're running out of time. So is there a burning question? I mean, a really burning and a really good one, Sam. Are you sure it's good? All right. We have one burning question from Sam. It's going to be really good.
No pressure.
Yeah, thank you so much, Professor Louis, for this talk. And my question is that because you talk about how science may not answer some of the big questions, actually almost like almost like religion or religious faith actually only answer this big question. But for majority of the believers, they may not wrestle with big questions. They may only wrestle with existential issues. I just wonder whether you could talk about existential actually value of religious faith rather than answering some of the big philosophical questions.
Yeah, so I think if I understand you right, I focus now on what I was trying to actually do was something a little simpler than claiming that religious faith answers these big questions. I was just going to say that science doesn't. Okay, so you could be non-religious and simply but you got to find those answers from somewhere, and so you should explain where those answers come from. And you may use lots of philosophers think very carefully about these big questions, and don't use scientific method, but use other methods to try to come to the reasoned conclusions. And that's a really good thing to do. That's different from saying that there are also questions like existential questions, questions of meaning and value, and questions that are existential. So if you're religious like I am, you believe there's a God who loves us and cares for us. This has a big impact on who you think you are, what you think the purpose of your life is, what you want to live like. Those are not generic questions for everybody, but for you yourself. Right? And everybody wants to have answers to those questions, and religious belief helps you to think those things through. And that's super valuable.
So on that note, we have to end, I'm afraid. But thank you so much for coming. But please join me in thanking our once more time for a wonderful, wonderful session together. Thank you.